We're going to continue in this segment with a little bit more information about the z-table. As a quick refresher, again, column A represents z-scores, column B represents the area between the middle of the distribution or the mean and a particular z-score, and then column C represents the area beyond that particular z-score. Another way of discussing the area beyond a particular z-score is to talk about it as being in the tails of the distribution. Here's another handout that you may have seen in the materials in the folder for this week. And again, nothing new here. We have the normal curve, we have the abscissa. Note that we have z-scores orienting the abscissa, z of 0 in the middle, a z of 1. That's one standard deviation to the right of the mean. That's very important to understand. One standard deviation to the right of the mean. Two standard deviations to the right of the mean would fall right there. Three standard deviations to the right would fall right there. Z of 0 in the middle. One standard deviation to the left. Two standard deviations to the left, three standard deviations to the left. Now, I've also, as you can see, hopefully, entered in specific amounts of area under the curve. That's how that's referred to, area under the curve, into these various segments. And as you can see, we are seeing symmetry being expressed on this drawing. And I got these areas from the z-table, or the normal probability distribution, pages 386 and 387. So, for example, this is a z of 0, that's the mean, the middle. This is a z of 1. If I go to the table and I look up a z of 1, I see that a z-score of 1, and if you want, go ahead and pause this video, get out the z-table and look at it as well. A z-score of 1 has an area of 0.3413. Roxy is having a bad dream in the background. Roxy, wake up. It's okay. 0.3413, that's the area between a mean and z of 1. Now, also, remember one of the properties of the normal probability distribution? One of the properties is symmetry. So we know right away, and we don't even have to look at the table because we've already looked at it, the area between the mean, or a z of 0, and a z of -1 is also 0.3413, all right? Now, proportions, 0.3413, those can also be expressed as percentages. All you have to do, much like when we were discussing the rectangular distribution, all you have to do is move the decimal point 2 places to the right. Excuse me. Move the decimal point 2 places to the right. So a proportion of 0.3413 would translate into a percentage of 34.13%, right? Also, the area between a z of 1 and a z of -1 would be 0.3413 plus 0.3413, or 0.6826, for example. So this piece all together would be 0.6826. Now, go back to the z-table and check out a z-score of 1.00. When I look at the z-table and I see a z-score of 1, column A, a z-score of 1, and I move my finger over to column C, the value I see, and hopefully you do too, is 0.1587. That's the area beyond a z of 1. So here's our z-score of 1. The area beyond that z, this portion right here, is 0.1587. Likewise, due to symmetry, the area beyond a z of -1 is also 0.1587. Also, since we're talking about a probability distribution, how much of the area, or how much area, is under the whole curve? How much area is under the whole curve? Well, what's 0.1587 plus 0.3413 plus 0.3413 plus 0.1587? I don't even need a calculator. I know the answer is and has to be 1, because the area under the curve is always 1 or 100%. Likewise, what's 0.3413 plus 0.1587? Quick, what is it? Well, you already know. If we're talking about an entire half, it's 0.5000. Half the distribution, half of 1, half of 100% would be 50%. So that's just a little bit more information about orienting ourselves toward the z-table. The z-table shows us numerically the specific areas under the curve. Remember, the table is symmetrical. You won't see negative z-scores on the z-table because you don't need them. You only need half of the table. You only need half of the distribution to navigate it because the other half is exactly like it. It's a mirror image.